Hi everyone. In the given problem statement of candy, we have been given n children which are standing in a line. Each child is going to be assigned a rating value given in an integer array ratings. You are given candies to these children subject to do the following requirement. Each child must have at least one candy, and the child with a higher rating gets more candies than their neighbors. So in order to solve this is going to be a greedy approach problem. The understanding could be a little bit intuitive. You have to figure it out. But let us take this example. We have a rating and the value of it is going to be 1, 0, 2. Now our result is going to, we can going to initialize our array with our value of all of them must have at least one candy. So we are going to give them all one candies. Now we are going to iterate through this loop in the left to right side. So for the first one, we can ignore it, but the second one, right? We are going to compare, is the second child have a higher rating compared to the first child, which is no. So that is fine. Now the question is that whether this rating 2, this child has a higher rating compared to this previous one, which is true. So our new rating values are going to be 1, 1 and 2. So here, right, number of chocolates we have distributed is going to be 4. Now we are going to traverse it from the right to left order. So now the first thing is that this, we are going to take this index. Is this child have a higher rating compared to the other one, means on the right hand side, which is not true. This has a 0 rating. Now when you come to this 1 value, does this 1 have a higher rating compared to its previous neighbor, which is true. So our rating value is going to be again modified to 2, 1, 2. The total number of chocolates is going to be the sum of these values, which is going to be 5. So here, right, if you have to just iterate through from left to right and then again from right to left, so this is going to give you an intuitive answer for this greedy approach. So that's all. Now let us go into the Python implementation of the given solution. Let me first initialize the values of candies, which is going to be of length 1. So it will be length of ratings. Now we are going to loop through the entire list. So for I in range 1 to length of ratings, if ratings of I is greater than ratings of I minus 1, means the ratings of this current child is greater than the ratings of the previous child, then in that case we are going to increment candies of I plus equal to 1. Once that is done, we are going to reverse or iterate through the loop in the reverse order. So for I in range length of ratings minus 2, we are going to till 0, so you have to give an index which is minus 1 and the step is going to be minus 1. Now the condition is that the ratings of the child, so if the ratings of I is greater than the ratings of I plus 1, in that case the candies of the ith child is going to be max of candies of ith child, or if the candies of the, let's say for example in this case, right, this child already has, let's say, 4 candies, okay, and this child, right, already has 2 this child already has, for example, 6 or 5 candies, right? So in that case we want to take the max value. So candies of I plus 1 plus 1, whichever is the maximum, right? We are going to take that, and we are going to return the sum of candies. And if I run this code, it should return properly. Let's check. Yes, the public test case is passed. Let me submit the code. Okay, there are some mistakes, which is returning an output of 12. Let me check. Okay, here I have done one smaller mistake. It is not always we're going to increment by plus 1. We have to increment the value. Means whatever the previous child has, right? It should be more than that. So it would be plus 1 and run it. It should not be plus equal to, it should be equal to. And if I click on submit, this time I'm pretty sure it's going to run properly. And as you could see, it runs successfully. The time complexity of this is going to be, there are 2 loops. So 2n, and also you're doing a summation. So it would be like 3 big O of n, or you can say just big O of n time complexity, which is pretty efficient. And as you could see, right, it beats 72.62% of the submission, which is a great number. So that's all for this video. See you in the next one.